Now we're going to study the next method, which is an extension to the payback period method, that is discounted payback period. So far, you must have realized that discounted payback period has one of the biggest limitations, that is, it does not account for the present value of the future cash inflows, which is highly an inappropriate technique to judge a project, right? That limitation is compensated, or you can say that limitation is eliminated entirely by using the discounted payback period method, or you can say the discounted cash flow analysis. In the discounted payback period method, you eliminate the payback period flaw by discounting the future cash flows appropriate values to the appropriate values. Now that discount rate will be the company's. If it's not mentioned, if it's not provided to you, you safely assume that it's the same rate of return required by the company for any project. That will be your discounted rate of return, or you can say the discount rate to arrive at the present value of the future cash flows. In discounted payback period method, we have to calculate the present value of each of the cash inflows, taking the start of the first period as 0 point. Okay, the first cash inflow point is a 0 point. That is when you invest or when you make the cash outflow. That is as happens. 0 point means that the value will be 1. It's exactly the same as we do in the net present value, right? If you recollect the fact how we had done the cash inflow present value computation, it's going to be exactly the same. Challenge over here is that you have to use a cumulative cash flow approach like we had done in the previous payback period method for the last example, where we had an uneven cash inflows coming in at various point of time. Now, the discounted cash flow for each period is computed by a formula, that is discounted cash flow is equal to actual cash flow divided by 1 plus interest rate raised to the power of n, and that is the exact formula for the present value of cash inflows. If you recall the formula which we had done in understanding the present value factors, in understanding the present value computation, that was also present value of future cash, or you can say future value of the cash inflows divided by 1 plus interest raised to the power of n, 1 plus rate of return raised to the power of n. That's exactly the same formula which we're going to use for the discounted cash flow over here. Now, once we have the discounted cash flow formula, the entire procedure is same as it was when we were doing a payback period which had uneven cash flows coming in. So that can better be explained with the help of an example. Let's start with the example itself now. Now we have your discounted payback. So let us say an initial investment of let's say $232,400, 232,000, okay, is expected to generate $600,000 per year for 6 years. Calculate the discounted payback if the expected rate is, let's say, 10%. Okay, so first we're going to prepare a table which is going to compute the discounted cash flow of each period by multiplying the actual cash flow to the present value factor. So here we have is let's say the cash flow scenario over here, present value factor at 10%. You have your discounted cash flow. So here we're going to understand year 0, 1, 2, 3, 4, 5, 6. For year 0, we're going to incur the initial cash outflow of $2,324,000. Okay, and you're going to have an every year annual cash inflow of $600,000 till the 6th year. Now we're going to look at the present value factor table for 10%. For the first year, it's 0.9091. So it's 0.9091. Next year, it's going to be 8264. So it's 0.8264. The third year, it's 0.7513. 0.7513. Fourth year, it's 0.6830. 0.6830. Fifth, 0.6209. 0.6209. And lastly, sixth year, it's going to be 0.5645. 0.5645. Over here, it's going to be 1. Now, as we had done in the present value computation, I want to multiply this entirely. Use the same formula. Dollar value Okay. Now we're going to put the one more additional step, which is going to help you figure out where does your payback period lie. It's going to be cumulative discounted cash flow. Okay. So here we're going to have the same minus figure, $2,324,000. And as you realize, this goes on decreasing because you initially made a negative investment, like your cash had gone out, and then you're starting to receive money against that, which is discounted to the present value. So obviously your cumulative cash flow will keep on reducing from negative and ultimately turn out to be positive. In which year it turns out to be positive is in the 6th year. But it does not need the entire $338,700 of cash inflow in 6th year. It just needs this $49,580. So what we're going to do is use the same equation as we had done previously. That is, we're going to figure out how much is the difference over here. Out of $338,700, we just need $49,580, right? So we're going to compute the fraction amount over here. That is, the discounted payback period will be equal to 5 years plus $49,580 divided by $338,700. That's gonna be a fraction of 0.15. So it's gonna be 5 years, 5.15 years. Okay, so this is how you get your discounted payback period. It's very easy once you understand the discounted cash flow concept and you start applying it. That's why hence we had told you the present value computation is going to play a really crucial role in all your future computation, most of the techniques of project value evaluation. As for now, I hope you have a good understanding of your discounted cash flow analysis. Okay, that's it for the time being, guys.